The moon hangs in the sky like a quiet thought, always there, always watching. Its silver glow has guided tides, migrations, and dreams for as long as there have been eyes to look upward. Yet for all its constancy, the moon is not still. It is forever in motion, forever falling, forever escaping, held in a delicate balance between the pull of gravity and the momentum of its own flight. What we see as calm is, in truth, a dance so precise that it has endured for more than 4 billion years. To imagine how gravity keeps the moon from flying away, picture something familiar. You stand in a field and throw a ball. The harder you throw, the farther it travels before curving back down to Earth. With just enough speed, your throw could carry the ball completely around the planet. If it could pass through clouds, mountains, and oceans without resistance, it would circle endlessly, always falling toward Earth, but never striking it. That is an orbit. The moon is a ball thrown once, long ago, with the perfect velocity to keep it forever curving around our world. If gravity were to vanish, the illusion would break. The moon would cease its endless fall and continue in a straight line along its path, drifting forever into the dark. The two bodies would part ways, their partnership undone. Without Earth's pull, the moon would not circle. Without the moon, Earth's tides and rhythms would falter. The invisible bond of gravity is what transforms motion into orbit, chaos into harmony. In truth, the moon's path is not a perfect circle, though it appears so in our sky. It is an ellipse, stretched slightly by the tug of the sun and the tilt of Earth's axis. But the underlying principle remains the same: motion and gravity balance perfectly. The moon moves sideways fast enough to keep missing Earth as it falls toward it. Its path curves smoothly through space-time, never reaching the surface, never breaking free. This motion is not forced, it is natural. In Newton's universe, an object in motion will continue in a straight line, unless acted upon by a force. The moon's motion was once straight, but Earth's gravity bends its path, curving it into perpetual fall. The balance between these two motions, one striving for escape, the other for capture, defines what we call an orbit. Each night, as the moon drifts across the sky, we are witnessing that equilibrium made visible. It is tempting to think of the moon as circling Earth like a marble rolling around a bowl. But the truth is subtler. Both Earth and moon orbit their shared center of mass, a point located deep beneath Earth's crust, but not exactly at its center. The two bodies move together, partners in a gravitational waltz. Earth tugs on the moon, but the moon tugs back. The slight rocking of our planet as it responds to that pull reminds us that no mass, no matter how large, is immune to gravity's reciprocity. This shared motion keeps the pair locked in an intricate embrace. The moon's speed, about 1 kilometer per second, and Earth's gravitational pull are matched so precisely that each revolution takes about 27 1/3 days. Over that time, the moon travels more than 2 million kilometers through space. Every moment, its velocity tries to carry it straight ahead, and every moment, gravity pulls it inward. The result is a path that never ends, a continuous falling that never arrives. Look again at the night sky and realize that what you see is not stillness but motion on a grand scale. The moon is moving faster than any airplane, faster than sound, tracing a path that took billions of years to settle into its current form. It circles Earth not because of some unseen string, but because space itself is curved by mass, and motion through that curvature creates orbit. The moon does not need to be pushed or steered. It follows the geometry of gravity itself. In this sense, the Earth-Moon relationship is both mechanical and poetic. It is a clock, keeping time with precision. It is also a story, one of balance, tension, and beauty. If the moon moved faster, it would escape into the void. If it moved slower, it would spiral inward and crash. Only within a narrow band of speed and distance can this cosmic dance endure. And endure it has, carrying the two worlds through the ages. To truly understand this balance, we must go deeper into the invisible field that binds them, into the mathematics that describe the pull of one world upon another. For the moon's flight, as graceful as it seems, is ruled by an ancient law written in the gravity between all things. To grasp why the moon stays in orbit rather than falling straight down, one must feel what gravity truly is, not as an abstract equation, but as a universal conversation between motion and attraction. The moon does not hang in space like a lantern on a string. It moves freely, its path shaped by the pull of Earth's gravity and by its own forward motion through the emptiness. The secret lies in the perfect compromise between falling and flying. If you could somehow stop the moon's motion in an instant, freezing it in space, gravity would seize it completely. The moon would begin to fall directly toward Earth, accelerating as it came closer, until the two worlds met in an impact of unimaginable violence. Yet, if you could increase its speed slightly, giving it a stronger push sideways, the moon would begin to spiral outward, its path loosening from Earth's grip until it broke free. Its orbit depends on balance. Too slow and it falls, too fast and it escapes. The speed it actually has is just right, a golden thread between captivity and freedom. This balance between gravity and motion is the foundation of orbital mechanics. Newton described it centuries ago in simple but astonishing clarity. Imagine a mountain so high that its summit rises above the atmosphere. From there, fire a cannonball. A weak shot sends it arcing back to Earth. A stronger one sends it farther, curving more gently. Fire with perfect speed, and the ball never lands. It circles the Earth forever, always falling, always missing. That is the same dance the moon performs. Gravity gives the moon's path its curve, while inertia, the tendency of an object in motion to keep moving, gives it flight. Together, they create a steady orbit. The moon's inertia tries to carry it forward in a straight line, but Earth's gravity bends that line into a closed loop. It is not a war between motion and force, but a partnership. Motion keeps the moon from crashing, gravity keeps it from drifting away. This is why the moon's journey is both endless and serene. It moves at roughly 1 kilometer per second, fast enough to travel the distance from New York to London in about 7 minutes. And yet, from our perspective on the surface, it seems motionless, rising and setting with quiet grace. We see only a gentle glow moving across the stars, unaware that it is perpetually plunging toward us, its fall diverted by its own velocity. But the dance is not just about the moon moving around Earth. The two are entwined in a mutual orbit. Earth, far heavier, moves too slightly, but measurably. The common center around which they both revolve lies about 4,600 kilometers from Earth's center, within the planet's interior, but offset enough to cause a subtle, rocking motion. This shared motion ensures that the moon does not simply revolve around Earth like a slave around a master. They are partners, bound by the same invisible rule that governs all matter in the cosmos. If we could watch the system from afar, we would see Earth and Moon moving together through space, curving around the Sun in a slow spiral. The Moon's path around the Sun is never a simple loop. It undulates, sometimes slightly concave, sometimes slightly convex, always weaving around the Earth's own solar orbit. The Sun's gravity tugs powerfully on both worlds, yet it never steals the Moon away. The reason lies in the balance of motion. The Moon travels through space as part of Earth's gravitational domain, moving so that the Sun's pull stretches the orbit, but does not break it. It is a partnership within a partnership, a celestial choreography so stable that it has lasted almost the entire history of the solar system. When seen through this lens, the Moon's orbit becomes a perfect metaphor for the universe itself, a harmony of opposites. It is free, yet bound, independent, yet connected, eternal, yet ever-changing. Gravity gives it direction, and motion gives it meaning. Together, they create a rhythm, older than life. This balance is so precise that even tiny changes ripple through the system over millions of years. The pull of other planets, the drag of tides, the shifting mass of oceans and continents, all of these slowly alter the Moon's path, but the principle remains constant. The Moon stays in orbit not because of some fragile equilibrium ready to collapse, but because gravity and motion form a self-sustaining cycle. If the Moon drifts outward, gravity weakens slightly, slowing the rate of drift. If it drifts inward, gravity strengthens, pulling it back into place. It is a balance maintained not by perfection, but by nature's self-correcting grace. This is the wonder of orbital motion. The Moon is not chained to Earth. It is free, yet forever returning. It moves through space not by defiance of gravity, but by harmony with it. To understand this harmony more deeply, we must now look more closely at the invisible hand that guides it, gravity itself, the quiet force that binds worlds, stars, and galaxies into one continuous whole. If you could step outside the solar system and look back, you would not see the moon tracing neat circles around Earth like a marble on a string. You would see two worlds twirling through space together, both moving around the sun, their paths woven into a single braided line of light. Earth and moon travel side by side, gravity keeping them bound in a dance so subtle that it appears effortless. The moon does not chase Earth, nor does it lag behind. It moves as if held by invisible rhythm, every curve of its orbit synchronized with the beat of Earth's pull. This is the cosmic balance that defines an orbit. In every moment, the moon is falling toward Earth, and in every moment, it is moving fast enough to miss it. Its forward motion creates the curve that replaces the fall. If it were somehow stopped, gravity would pull it straight down, and the two worlds would merge. But because it is always in motion, always gliding forward, the fall becomes endless. It is the perfect paradox: motion that creates stillness, descent that never arrives. The same principle holds for every moon, every planet, every star that circles another. Mars's moons tumble in miniature versions of the same motion. The planets themselves fall forever toward the sun, and the sun falls toward the center of the Milky Way. Even galaxies fall toward each other in great spiraling motions. Everywhere in the universe, gravity and motion perform the same timeless dance, falling and missing, attraction and escape. The moon is simply our nearest witness to this grand choreography. What makes the moon's case special is how intimately we feel its effects. Its pull stirs our oceans. Its light touches our nights. Its movement keeps time with our calendars. Yet behind this familiarity lies the same majestic law that binds galaxies. The equations that describe the moon's orbit are the same that describe the motions of stars around black holes and the paths of galaxies through clusters. Newton's insight, refined later by Einstein, revealed that there is no separate set of rules for near and far, for small and vast. The same curvature of space-time, the same attraction of mass and energy, shapes it all. When you watch the moon rise, you are seeing not a passive satellite, but a world caught in this endless exchange. The energy of its motion and the pull of gravity are locked in perfect equality. It is a relationship so precise that even the smallest shift would alter everything. If Earth were a little lighter or the moon a little faster, the balance would break. The moon might drift away into cold isolation or spiral inward to destruction. But the numbers align perfectly, a cosmic harmony that has lasted since the time when molten rock cooled into oceans and continents. The stability of this orbit gives Earth its rhythm. The months we count, the tides that shape our shores, even the slow wobble of Earth's rotation, all trace back to the moon's motion. It is not simply a companion, but a governor, a metronome keeping the tempo of our planet's movements. Without its steady pull, Earth's axis would wander more wildly, our days and nights would drift out of sync, and the pattern of life itself might have evolved differently. Gravity is not just a force that holds it, is a sculptor that carves time itself into rhythm. The moon's orbit also reveals something profound about energy. Every bit of its motion represents stored energy, a balance between kinetic movement and gravitational potential. In orbit, these two constantly exchange, yet the total remains constant. When the moon moves closer to Earth, gravity strengthens and speed increases. When it drifts outward, gravity weakens and speed decreases. This interplay defines the orbit's graceful ellipse, an endless conversation between falling and flight. Energy does not vanish, it changes shape, flowing between motion and pull like breath, between inhale and exhale. It is tempting to imagine this balance as fragile, as if one wrong step could undo billions of years of stability. But nature works differently. Orbits are not delicate, they are resilient. If disturbed slightly, they adjust, finding new paths that preserve the dance. The moon's orbit has stretched and shifted countless times by impacts, tides, and even the drift of continents, yet it remains bound. Gravity has no weakness in patience. Given enough time, it restores balance. And so, when we look at the moon and wonder why it does not drift away, the answer is not mechanical, but elegant. It stays because motion and gravity are not enemies. They are partners. Gravity bends motion into curves, and motion keeps gravity from collapse. Together, they form an unbroken circle that can last longer than mountains, oceans, or species. This is the first truth of the moon's existence. It is not a prisoner of Earth, nor a rebel fleeing it. It is a companion, held in perpetual balance. The same invisible hand that holds the planets in their paths holds the moon in ours. Its orbit is proof that motion and attraction can coexist, that the universe finds harmony even in opposing forces. To truly understand the nature of this invisible bond, we must look deeper into the law that governs it, the force that reaches across space, binding every atom to every other. For while the dance between Earth and Moon is beautiful to behold, the power that drives it is more profound still. It is the invisible tug of gravity, a universal language written into the structure of reality itself. Gravity is the quietest of forces, yet the most relentless. It cannot be seen, heard, or touched, but it holds galaxies together, shapes the fall of rain, and bends the paths of moons. In the vast stillness between Earth and Moon, this invisible tug never rests. It pulls without pause, threading an unbreakable line through space and time. The moon does not orbit because it wants to, but because gravity allows nothing else. It is a force without mercy or malice, a law that simply is patient, universal, and absolute. When Isaac Newton looked at the moon in the late 1700s, he realized something astonishing. The same force that makes an apple fall from a tree also holds the moon in its path. The apple falls straight down because Earth's gravity pulls it toward the center of the planet. The moon is falling too, but its sideways motion keeps it in orbit. What seems like two different phenomena, falling and circling, are in fact one and the same. It was one of the greatest unifications in human thought. Newton's law of universal gravitation can be spoken simply: every object in the universe attracts every other object, with a force that depends on their masses and the distance between them. The greater the mass, the stronger the pull. The farther apart, the weaker it becomes. There are no boundaries to this attraction. It reaches across the cosmos, though its strength fades with distance. Every atom in your body pulls gently on every atom in the moon. The effect is too small to feel, but it is real. The pull between Earth and Moon is immense. The moon's gravity lifts Earth's oceans, drawing the tides that sweep along our shores. Earth's gravity in turn pulls the moon, keeping it from drifting away. The strength of this mutual attraction is roughly 1/6,000th of the sun's pull on Earth. Yet the moon orbits Earth rather than the Sunday. The reason lies not in sheer strength but in proximity and motion. The moon is close enough that Earth's gravity dominates within a region of space called its gravitational sphere of influence. Inside that sphere, Earth rules. The sun's gravity still tugs at the moon, trying to pull it free, but Earth and Moon move together around the sun in harmony. The entire system, Earth and Moon, orbits the sun as one. This is why the sun cannot steal the moon away. The moon's motion around Earth is fast enough and tight enough that it remains within Earth's grasp. The two bodies are like dancers circling each other while moving together across a grand ballroom. The sun provides the floor beneath them, but the dance belongs to Earth and Moon. It is this delicate balance that makes the moon's orbit stable. Were the moon slightly farther away, the sun's influence might overpower Earth's, and the moon could be lost to space. Were it closer, the tides and gravitational stresses would tear it apart. Nature, through billions of years of motion, has found the perfect middle ground, a distance of about 384,000 kilometers, where the forces of gravity and inertia match perfectly. To understand the invisible tug itself, imagine space not as emptiness, but as a vast sea. In this sea, every mass creates a subtle current, drawing other masses toward it. The larger the mass, the stronger the current. Earth creates such a current around itself, and the moon drifts within it, forever pulled toward the center, yet never falling in. This image captures what Newton's mathematics expressed in numbers, that gravity is a universal attraction, invisible but omnipresent, shaping everything from a falling leaf to the path of the planets. Gravity does not need wires, particles, or visible connections. It acts instantly across space, linking all things through the simple truth that mass attracts mass. It is the quiet architecture behind every structure in the cosmos. Planets orbit stars, stars gather into galaxies, galaxies into clusters, all following the same law. The distances and scales differ, but the pattern is identical. From the smallest pebble to the largest black hole, gravity weaves them into one fabric. And yet, the beauty of gravity lies not just in its reach, but in its restraint. It is the weakest of all fundamental forces. Compared to electromagnetism, to the nuclear forces that bind atoms, gravity is almost nothing. You can lift a paperclip against the entire pull of Earth with a single magnet, and still, over vast distances and deep time, gravity prevails. It builds planets, ignites stars, and carves the geometry of the universe. Weakness, multiplied by infinity, becomes power. In the space between Earth and Moon, gravity stretches like a taut thread, invisible but constant. It is not perfectly uniform. On the side of Earth nearest the Moon, the pull is slightly stronger. On the far side, slightly weaker. These differences create tides, slow movements of water and rock that carry energy back and forth across the planet. The Moon's gravity is not just a distant force, it is a living influence, felt every day in the rise and fall of oceans, the flexing of continents, and even the subtle rhythm of our planet's rotation. To the naked eye, the Moon's orbit looks tranquil, but gravity's work is ceaseless. Every second, trillions of tons of ocean water move in response to that pull. The Moon rises slightly ahead of where it did the night before, because Earth has spun beneath it, and the balance between their motions must adjust. Gravity never sleeps, never pauses, never lets go. It is the silent conversation between worlds, written in the language of curvature and motion. And yet, this invisible connection is only half the story. Gravity pulls, but motion preserves the balance. The Moon does not crash because its motion keeps it perpetually falling and missing. The deeper truth is that the two, motion and gravity, are inseparable. To understand one, we must study the other, for together they create the delicate geometry of orbit that holds the Moon where it is, neither lost nor captured, but eternally poised between. To imagine the pull between Earth and Moon is to imagine something that never ceases. Gravity does not flicker on and off. It is constant, unwavering, and everywhere. It is not electricity that needs a circuit, nor magnetism that requires poles. It is the most democratic of forces. Every bit of matter, no matter how small or humble, contributes its share. The dust under your feet, the oceans, the mountains, every atom of air participates in this universal attraction. Earth tugs on the Moon, and the Moon tugs on Earth, both locked together in a dialogue that began 4.5 billion years ago and will continue for billions more. It is difficult for the mind to grasp such persistence. We are used to forces that fade with distance or exhaust themselves with time. Throw a stone, and friction brings it to rest. Strike a bell, and the sound fades. But gravity does not weaken from exhaustion. It weakens only with distance. Double the distance, and the strength drops to 1/4. Triple it, and the strength falls to 1/9. Yet it never truly reaches zero. Its influence stretches endlessly, a whisper that grows faint, but never silent. This endurance means that no mass in the universe is truly isolated. Every star feels the presence of every other star. Every planet is tugged slightly by every other planet. The moon feels not just Earth's gravity, but also the gravity of the sun, the planets, and even the stars of the Milky Way. The effect of these distant forces is minute, but real. The universe is a web of invisible threads, each one a line of gravity connecting all things. The Earth-Moon connection is a small but vivid part of this tapestry. The pull between them is about 2 trillion newtons, an unimaginable force, yet balanced perfectly by the moon's motion through space. The moon falls toward Earth, but its speed bends that fall into orbit. This delicate equilibrium is so precise that even the smallest change would alter everything. Increase the moon's velocity by a few meters per second, and it would climb into a wider orbit. Decrease it, and it would spiral slowly inward. Gravity leaves no room for error, yet the cosmos finds balance naturally, as if harmony were built into its laws. The sun, though vastly more massive than Earth, cannot steal the moon because of this harmony. The sun's gravity does pull harder on both bodies, but it pulls almost equally on them both. Since the moon orbits Earth while both orbit the sun together, the relative pull between them remains stable. It is a cosmic version of standing in an elevator. The floor and your body are both pulled downward at the same rate, so you do not feel weightless collapse. The Earth and moon fall around the sun together, and in that shared fall, their bond endures. When Newton realized this, it changed everything. For the first time, humanity saw that the same force guiding an apple's fall also governs the motion of the heavens. The world above and the world below were one and the same. The moon's path was no longer a mystery belonging to gods or myths. It was a physical law, measurable and predictable. That revelation unified heaven and earth under one rule: gravity. It was not merely a discovery of science. It was a reordering of thought. Gravity's reach does not stop with orbits. It shapes time itself. As Einstein later revealed, gravity is not a force that acts across space, but the very curvature of space and time caused by mass and energy. When you stand on Earth, what you feel as weight is not a pull downward, but the shape of space-time guiding you toward the planet's center. The moon's orbit is not a path drawn by force, but by geometry. It is following the curve of space-time around Earth. In this way, Newton's invisible tug and Einstein's bending of space are two expressions of the same truth. Matter and energy tell space how to curve, and curved space tells matter how to move. Yet, for all our mathematical understanding, gravity retains a touch of mystery. We can describe its behavior perfectly, but we still do not know why it exists. We know it binds galaxies, but not why it is so weak compared to the other forces of nature. We know it shapes the universe, but we do not yet know how it fits with the quantum world of the very small. The invisible tug remains the most familiar and the most enigmatic of all natural laws. On Earth, we feel its pull as normal, almost trivial. We forget that our very sense of up and down is a product of gravity. The moon feels it too, though differently. It is constantly in free fall, forever tumbling through the curved space-time around Earth. The same attraction that makes you fall when you trip is what holds the moon in its orbit. The difference is one of scale, not of kind. Every fall, every orbit, every trajectory follows the same law. If you were to turn off gravity, the illusion of order would vanish. The oceans would drift into space. The air would follow. The moon would shoot off into the dark. Even the planets would abandon the sun, traveling in straight lines forever. The beauty of the night sky, the cycles of phases, eclipses, and tides depends entirely on this invisible connection. Without gravity, there would be no orbits, no warmth from stars, no galaxies. Gravity is the thread that sews the universe together. And so, between Earth and moon, across the silent void, this tug continues unbroken. It is not a force of violence, but of constancy. It holds, steadies, and guides. It does not command, but persuades. The moon's loyalty is not imposed, but earned through balance, a perfect accord between motion and pull. It is this equilibrium, maintained by the gentlest of influences, that has allowed both worlds to move together through cosmic time. The invisible tug of gravity is more than a physical law. It is a story of connection of two worlds, bound by something they cannot see yet, cannot escape. The next step is to see how this connection interacts with motion itself, creating the extraordinary state of balance that allows the moon to fall forever without ever falling down. In the silence between worlds, gravity does not rest. It pulls, adjusts, and balances endlessly. The moon's path is not a static loop drawn on the backdrop of space. It is a living motion, shifting gently as the two bodies exchange energy and influence. What appears to our eyes as a perfect circle is in truth a grand compromise between countless forces: the pull of Earth, the sway of the sun, the subtle tug of other planets, even the deforming tides that rise and fall on both Earth and Moon. And through all this, gravity remains the unbroken link that keeps the system whole. From our vantage point on Earth, we see the moon wax and wane, drift across the sky, and vanish behind clouds or into the shadow of eclipse. But beneath these cycles lies something far greater, an unending conversation between motion and pull. The moon's velocity tries to carry it straight onward, but Earth's gravity curves that motion into a path. The moon answers by tugging back, raising tides, and slowing Earth's rotation ever so slightly. The two bodies are locked in feedback, each shaping the other's future. To imagine this, think of two dancers on a stage. One moves forward, and the other holds their hand, drawing them back into a turn. The steps are fluid, the balance precise. If either partner hesitates or moves too fast, the rhythm falters. But in harmony, they spin as one, each guiding and guided. That is the relationship between Earth and Moon. Gravity is the hand between them, invisible, tireless, and impossibly strong. What makes this connection so extraordinary is how far it reaches and how delicately it operates. The moon orbits at nearly 400,000 kilometers from Earth, yet the pull that binds them is exact to the smallest fraction. If gravity were weaker by only a tiny degree, the moon would slowly drift away until it was lost. If it were stronger, the moon would spiral inward and shatter under tidal forces. The actual strength is perfect, as if the universe itself tuned it to balance motion and attraction. But this perfection is not static. Over time, the dance evolves. The moon is not circling endlessly on a frozen track, but gliding outward, ever so slowly. The pull of Earth's oceans on the moon's orbit transfers energy between them. The rotation of our planet drags tidal bulges slightly ahead of the moon's path, creating a small forward pull that accelerates the moon and nudges it to a higher orbit. This shift is barely noticeable in a human lifetime, only about 3.8 centimeters each year, but over millions of years, it transforms everything. This tidal exchange is the heartbeat of the Earth-Moon relationship. Earth's day lengthens as the moon drifts away, conserving the total angular momentum of the system. Long ago, days were shorter, the moon nearer, tides higher. The story of gravity is not one of stillness, but of continual adjustment. The invisible tug is not a fixed rope, but an elastic thread, stretching and yielding, yet never breaking. Gravity's perfection lies in its patience. It allows the system to evolve slowly, gently, almost imperceptibly. Each tiny exchange of energy ripples outward across time. The moon's retreat, Earth's slowing spin, the subtle changes in orbit, all are notes in a cosmic symphony that has played for billions of years. From the chaos of the early solar system, gravity sculpted stability, transforming violent collisions into graceful motion. And yet, for all its quiet order, gravity also contains the seeds of change. It governs cycles that can span eons, cycles so vast that entire species rise and vanish while the dance continues. The same pull that keeps the moon close will, over unimaginable time, alter its distance until a new equilibrium forms. The dance may slow, but it never ends. Even as the system changes, gravity adapts, always finding the balance point between motion and stillness. The invisible tug between Earth and Moon is a lesson in how the universe sustains itself. It shows that power need not be loud, that stability need not be rigid. Gravity acts with no sound, no light, no signal, yet its effects are everywhere. It does not command, it invites. It does not collide, it curves. Through its gentle insistence, worlds move, stars form, and galaxies hold their shape. It is the ultimate mediator between chaos and order. As the Moon moves along its orbit, always falling, always flying, we are reminded of this hidden symmetry. The same pull that guides the Moon's journey holds us to the ground, keeps our oceans from drifting into space, and anchors the atmosphere that sustains life. Gravity is not only a cosmic law, but the foundation of our existence. It is the quiet reason that Earth has a moon at all, the invisible companion that links us to the heavens. So when we look up at the sky and see that silver circle tracing its slow path, we are watching gravity itself made visible, not as a number or formula, but as motion, grace, and balance. The Moon does not fall because gravity and motion are in perfect accord, each completing the other. This is the essence of the invisible tug, a relationship built on motion and pull, where neither dominates and both endure. And yet, this bond is not eternal in form. It evolves, shaping not just the orbit, but the very history of our planet. To understand how, we must follow this force beyond its simple pull and into its consequence, the tides that rise and fall, the energy that moves between worlds, and the slow outward journey that has transformed Earth and Moon for billions of years. The Moon's path around Earth is the perfect example of nature's precision, a balance so delicate that the smallest change in motion or distance would unravel it. To orbit is to fall and never land, to fly forever without escape. This is the paradox of celestial motion, the reason the Moon circles our world rather than colliding with it or vanishing into the dark. Its motion is neither chaos nor stasis. It is harmony written in the language of gravity and motion, two forces intertwined in an eternal compromise. To picture this balance, imagine standing on a high cliff. You throw a stone forward. The harder you throw, the farther it travels before the curve of Earth's surface causes it to strike ground. Throw it faster still, and the stone travels farther and falls more slowly. Now imagine throwing it so fast that as it falls, the ground curves away beneath it. The stone keeps missing Earth's surface, looping around endlessly. You have placed it in orbit. This is the essence of how the Moon moves a motion so fast that its fall never finds an end. Every second, the Moon falls toward Earth at roughly the same rate that Earth's surface curves away beneath it. The balance is perfect. Gravity pulls inward, motion carries forward, and together they create the smooth ellipse that defines the Moon's orbit. If the Moon's forward velocity were any slower, gravity would win, pulling it down in a slow spiral that would end in destruction. If it were any faster, motion would triumph, flinging the Moon away into space. The fact that it remains, circling endlessly, speaks to the remarkable equilibrium of the system. This dance is not unique to the Moon. Every planet, every moon, every satellite, every speck of cosmic dust that moves in orbit follows the same rule. It is the balance between the inward pull of gravity and the outward tendency of motion. The faster an object moves, the stronger gravity must be to hold it. The weaker the gravitational field, the slower the object must move to stay bound. This relationship governs everything from the tiniest orbiting particles near Saturn's rings to the enormous paths of planets circling distant stars. In mathematical terms, the Moon's speed in orbit is just right for the distance it maintains, about 1 kilometer per second, at roughly 384,000 kilometers from Earth. The two quantities are matched perfectly by nature. The result is a stable orbit that can last for billions of years. But the numbers alone tell only part of the story. The deeper truth is that this balance is not mechanical but dynamic. Gravity and motion are not frozen forces. They are continuous actions, adjusting moment by moment. Orbit is not a line drawn in space, but a process, a conversation between two movements. Gravity curves the path, motion resists the curve, and the outcome is a smooth compromise. To see the moon shining above is to witness this conversation in real time. It is a visible trace of invisible forces in perfect tension. The moon's orbit is nearly circular, but not entirely so. It is slightly elliptical, meaning that sometimes the moon is closer to Earth, and sometimes it is farther away. These points are called perigee and apogee, and the difference between them is about 40,000 kilometers. When the moon is at perigee, it moves slightly faster. When at apogee, it slows down. The change in speed ensures that energy and motion stay balanced. Gravity is stronger when the moon is near and weaker when it is far. But the orbital dance compensates with speed. This small variation is why we see supermoons and micromoons. When the moon's distance changes, its size and brightness shift slightly in the sky. Yet even as it waxes and wanes in our view, the underlying balance never breaks. The laws of motion keep everything in check, ensuring that the moon's path never wanders too close or too far. Orbit is a kind of falling that never finishes. It is the perfect marriage of momentum and pull. The moon is always moving forward, but because gravity constantly bends its path, that forward motion becomes a circle. The result is continuous free-fall motion in which the sensation of falling disappears because there is no ground to meet it. Astronauts in the International Space Station experience the same principle. They are falling toward Earth, but the station's forward velocity makes them miss it continuously. Their weightlessness is not the absence of gravity, but the perfection of its balance with motion. The moon, too, is weightless in the same sense, forever falling, forever free. This delicate interplay extends far beyond our skies. The planets around the Sun, the moons around Jupiter, the stars in binary systems, all are participants in this same celestial negotiation. Motion strives for straightness, gravity for curvature, and their compromise becomes orbit. It is one of the most elegant outcomes of nature's mathematics. The wonder of it lies not only in the precision but in the endurance. The moon has circled Earth more than 50 billion times since its birth. Each revolution preserves the balance anew, each path a testament to the unyielding reliability of physical law. The energy stored in that motion is immense enough that if gravity were somehow turned off, the moon would fly away forever, carrying its momentum unchanged through the darkness. Yet, gravity will never turn off, and motion will never stop. Together, they maintain the rhythm of the cosmos. The moon's orbit is a self-sustaining harmony, where falling becomes flying, and flying becomes falling. This is the heart of celestial motion, a dance that needs no music, a flight that needs no wings, but balance is never absolute. Over time, subtle influences shift the pattern. The moon's path evolves, stretched and tilted by the pull of the sun, the pressure of tides, and the slow transfer of energy from Earth's rotation. The orbit remains stable, but its parameters drift. To understand this slow change, to see how gravity and motion rewrite their own story across billions of years, we must look at the forces that act between the two worlds. Forces that move oceans, shape continents, and even lengthen the days. An orbit is not a static ring drawn through space. It is alive, in motion, ever adjusting to the pulls that shape it. The moon's path around Earth is a continuous exchange of energy, a cosmic negotiation between momentum and gravity that must be recalculated by nature at every instant. Though its orbit seems calm and perfect from the ground, it is constantly being corrected by the subtle tug of forces that reach across hundreds of thousands of kilometers. In the language of celestial mechanics, the moon follows an ellipse, a slightly stretched circle. When it is closest to Earth, At perigee, it moves faster. When it reaches apogee, it slows. This is not a flaw in the system, but a necessity. The balance between energy and gravity requires that when the moon falls deeper into Earth's gravitational well, it must gain speed to conserve energy. And when it climbs higher, it must lose speed. The result is a self-adjusting harmony that repeats month after month, an endless conversation between distance and velocity. Johannes Kepler described this pattern centuries before Newton revealed its cause. Kepler's laws of motion were born from observation, patient study of planetary paths. He noticed that every orbit was an ellipse, that planets sweep equal areas in equal times, and that their orbital periods relate precisely to their distances from the sun. Newton later explained why. Gravity provides the inward pull. Motion provides the outward momentum. The elliptical shape is simply the geometry that satisfies both at once. The moon obeys the same principle, tracing an orbit that is never exactly the same twice, yet always faithful to the laws that bind it. At perigee, when the moon is closest to Earth, gravity's hand is strongest. The moon moves at its fastest, covering more ground in less time. At apogee, when it drifts to its farthest point, gravity's pull weakens slightly, and the moon's speed drops. These shifts, though minute to us, are crucial to maintaining stability. Without them, the moon's path would spiral inward or outward. Instead, it oscillates smoothly, its energy traded back and forth like the rhythm of a pendulum. The shape of the moon's orbit is also tilted, inclined about 5 degrees to Earth's path around the Sunday. This tilt explains why we do not see a solar eclipse every month. Most of the time, the moon passes slightly above or below the sun from our perspective. Only when the orbits align perfectly do the shadows meet, and the sky darkens in the spectacle of eclipse. Even here, gravity is the unseen choreographer, deciding when these alignments occur through the slow procession of the moon's orbit over centuries. Every motion of the moon reflects a deeper truth about gravity's nature. It is both firm and flexible. The same law that holds the moon steady also allows for subtle variations, slight wobbles, and gradual shifts. These deviations are not signs of instability, but expressions of adaptability. Gravity does not impose rigidity. It allows freedom within boundaries. The moon is free to move, but never free to leave. Circular orbits are rare in nature because perfect balance is nearly impossible. There are always perturbations, slight pulls from other bodies, asymmetries in mass, tidal exchanges of energy. The moon's orbit is shaped by all of these. The sun's gravity elongates it slightly. The bulging of Earth's equator, due to its rotation, adds a small torque. Even the pull of planets like Venus and Jupiter, though weak, adds long-term variations that astronomers must account for when calculating the moon's exact position. Over time, these influences cause the orbit to precess, to rotate slowly, like a spinning coin that traces a widening spiral before coming to rest. From the ground, we notice none of this. The moon rises and sets with serene predictability, its rhythm older than any civilization, but high above, the geometry of its path is a masterpiece of compromise. The moon's orbit wobbles, breathes, and stretches, yet remains faithful to the gravitational embrace that defines it. This harmony between falling and flying, between curve and motion, is the foundation of all orbital stability. In a sense, every orbiting body lives on the edge of escape. One fraction more speed, and it would break free. One fraction less, and it would spiral inward. The precision required seems miraculous, but it is not chance. Nature finds this equilibrium naturally because of how energy and motion interact. Once a stable orbit forms, it tends to preserve itself. The forces of gravity and motion correct one another automatically. Consider the moon as it moves along its path. At perigee, as it approaches Earth and accelerates, its increased speed carries it outward again. At apogee, when it slows, gravity pulls it inward once more. The result is a perpetual balance, self-sustaining and self-correcting. This is the genius of the universe, a system that does not need external control, only the laws that were written into its fabric at birth. Even time itself bends to this rhythm. The length of a lunar month, roughly 27 1/3 days, is set by the balance between gravity and motion. This cycle determines tides, guides calendars, and marks the passage of countless generations. Every phase of the moon crescent, quarter, full, and dark is a visible echo of this invisible geometry. When ancient astronomers tracked the moon's changes, they were not just studying light and shadow, they were witnessing gravity at work. The more we study orbits, the more we see how fragile they might seem, and yet how enduring they are. The moon's orbit has survived asteroid impacts, internal shifts within Earth, and the slow drift of continents. It has persisted through epochs of change, holding steady against all perturbations. It is a balance so finely tuned that it has guided life itself, its regularity shaping tides that nurtured the first coastal ecosystems. The moon's orbit is more than motion. It is a contract between matter and space. It is a manifestation of order, born from the chaos of formation. When the moon first coalesced from the debris of a colossal impact, its path was far more chaotic. Over time, tidal friction and gravitational resonance sculpted its orbit into the near-perfect harmony we see today. The process took millions of years, but gravity is patient. It refines, adjusts, and stabilizes until equilibrium is achieved. To understand how this process continues even now, we must look more closely at the subtle forces still at work, the tides that stretch both Earth and Moon, exchanging energy and slowly altering their separation. The orbit we see today is not frozen in time, but evolving. Gravity never stops reshaping the dance, and in the next chapter, we will follow its most delicate and transformative expression, the tides that link the oceans of Earth to the motion of the Moon. An orbit, though steady, is never static. Over billions of years, the dance between Earth and Moon has changed in subtle yet profound ways. The perfect balance between falling and flying is not fixed forever. It shifts, responds, and evolves. Gravity has no hurry, but it has no rest. Every revolution of the Moon, every rising and falling of the tides, every slight slowing of Earth's rotation adds a new verse to the same endless song, the transformation of motion into time. When the Moon first formed, its orbit was far closer to Earth, perhaps only 20 or 30,000 kilometers away, so near that it would have loomed enormous in the sky, filling the horizon with its light. Its motion then was faster, its month shorter, and Earth's days only a few hours long. Gravity's pull was stronger, and the tides were unimaginable in size. The oceans would have surged hundreds of meters higher and lower, reshaping coastlines daily. That ancient chaos was part of the process by which the modern balance emerged. Over time, friction within Earth's oceans and crust began to dissipate energy. Each tide that rose and fell transferred a minute amount of rotational energy from Earth to the Moon. The result was slow but inexorable. The Moon began to move away, and Earth's rotation began to slow. This process continues today, invisible to us but measurable by laser reflections from mirrors left on the lunar surface. With exquisite precision, scientists have found that the Moon recedes by about 3.8 centimeters per year. The system adjusts, seeking a new balance, one that unfolds over billions of years. The current orbit, nearly 400,000 kilometers wide, represents a kind of truce between motion and pull. Earth's gravity keeps the Moon bound, while the Moon's momentum keeps it from falling inward. But the energy exchange never stops. The tides act as intermediaries, carrying momentum from the spinning Earth to the orbiting Moon. It is a transfer both graceful and relentless. The more Earth's spin slows, the farther the Moon drifts. The balance of falling and flying thus becomes a story of time itself. The length of our days, the timing of months, even the rhythm of life on Earth have been shaped by this slow, gravitational dialogue. Coral fossils preserve growth rings that record ancient days long ago. There were more days in a year, because each one was shorter. Over hundreds of millions of years, gravity has stretched the tempo of our planet, turning the quick rhythm of youth into the slow, measured beat of maturity. This is what makes orbits such profound teachers. They show us that motion is not separate from history. Every path through space carries with it the memory of energy exchanged, of forces balanced and reborn. The moon's orbit today is the result of 4.5 billion years of adjustment, the outcome of a cosmic negotiation that began in fire and now continues in silence. Yet the elegance of this balance conceals its fragility. Even small changes can accumulate over vast timescales. The sun's gravity elongates the moon's orbit slightly, stretching it at one end and compressing it at the other. Earth's equatorial bulge adds a slow twist to the plane of the orbit, causing it to wobble over thousands of years. The pull of other planets, especially Jupiter, introduces gentle oscillations that shift the moon's distance and inclination. None of these are large enough to break the bond, but all of them ensure that the orbit is never truly the same twice. If you could speed up time and watch the Earth-Moon system evolve, you would see the orbit breathing, expanding, tilting, and precessing in a vast rhythm. You would see the moon inching outward, Earth's spin lengthening, and the tides changing their patterns. You would see energy flowing invisibly between rotation and revolution, a grand exchange guided only by gravity's patient hand. The falling never stops, the flying never stops, and neither ever wins. Orbit, in this deeper sense, is not motion but relationship. It is the story of two bodies tied together by geometry and energy, always adjusting, never separating. It is the conversation between momentum and attraction, written across the vastness of space and the immensity of time. The moon does not circle Earth out of obedience, but because the laws of physics allow no other path so stable. It is the natural outcome of motion within curved space, the inevitable result of gravity's insistence that nothing ever moves alone. If you could stand on the moon and look back at Earth, you would see the same truth from another angle. The planet would hang in your sky unmoving, always showing the same face, its blues and whites glowing against the blackness. This stillness is an illusion born of the same balance that defines the orbit. The moon keeps one face toward Earth because tidal forces long ago locked its rotation to its revolution. The dance is mutual. While Earth turns daily, the moon turns once per orbit, keeping its gaze forever fixed on its companion. This synchrony is another form of balance, a gravitational embrace that has lasted for billions of years. And yet, this partnership will not last forever. As the moon drifts outward, the forces that sustain this balance will weaken. Earth's rotation will continue to slow until, in the far future, the same side of Earth always faces the moon, just as one side of the moon faces Earth now. The dance will reach its quietest form, two worlds turning together, locked in mutual stillness. But before that distant era arrives, there are still chapters to unfold, still energies to exchange, still tides to rise and fall. For now, the moon's orbit remains our anchor, the delicate balance between falling and flying that defines our sky. It is the perfect expression of gravity's dual nature: pull and motion, tension and release, constant yet evolving. And as we turn to the next chapter, we follow this motion into its most tangible expression on Earth: the tides, the slow heartbeat of the oceans, the living proof of how the moon's invisible hand reaches down to touch our world every day. The surface of Earth seems still to the casual eye, but it is never truly at rest. Every ocean, every bay, every stretch of water on this planet breathes in rhythm with the pull of the moon. Twice each day, the seas rise and fall, not by their own will, but because gravity stretches them. The tides are Earth's silent acknowledgement of the moon's presence, a slow, planetary motion that mirrors the invisible dance taking place between the two worlds above and below. When the moon pulls on Earth, it does not lift only the water beneath it. It tugs at the entire planet, Earth's crust, its atmosphere, even the very rock beneath the oceans. All respond to that pull, though water moves most visibly. On the side facing the moon, gravity's hand is strongest, drawing the oceans upward into a bulge. On the opposite side, the pull is slightly weaker, and inertia creates a second bulge as the planet itself moves under the influence of the moon. The result is two tides, one facing the moon and one opposite, that circle the Earth as it spins. But the story of tides is not just one of motion. It is also a story of friction, energy, and transformation. The Earth is not a perfect sphere, nor is its rotation uniform. The continents block and channel the movement of water. The ocean basins are irregular, and their depths vary. As Earth spins, the tidal bulges lag slightly behind the moon's position in the sky. This offset is small, but it changes everything. It is the reason the moon is slowly escaping from Earth's grasp. The lag means that the bulges are not directly beneath the moon, but slightly ahead of it, pulled forward by the rotation of the planet. The extra mass in those bulges exerts a gravitational tug on the moon, pulling it forward along its orbit. That small pull adds energy to the moon's motion, causing it to move outward, inch by inch, year by year. At the same time, the Earth loses an equal amount of rotational energy. Its spin slows down, making each day slightly longer. The law of conservation of angular momentum ensures that nothing is lost. It is merely transferred from the spin of the planet to the orbit of the moon. This is one of the most delicate and beautiful exchanges in the solar system. It is invisible, silent, and extraordinarily slow, but it shapes the history of both worlds. The tides that lap against our shores are not simply waves in the sea. They are the manifestation of a cosmic trade, Earth giving up its spin to allow the moon its gradual freedom. If we could speed up time and watch the process unfold over millions of years, we would see the moon spiraling gently outward, its orbit expanding as Earth's rotation slows. Each century, the day grows longer by a fraction of a second. Each millennium, the moon drifts a few meters farther away. In human time, it is imperceptible. In geological time, it is profound. The moon we see tonight is not the same moon that shone over the ancient oceans of early Earth. It is more distant, more serene, its path slightly wider. The friction that drives this process occurs deep within Earth's oceans and mantle. As the tides move, they rub against the sea floor, dissipating energy as heat. This tidal friction is one of the few ways in which Earth's rotational energy is continually converted into another form. Over eons, this has slowed Earth's spin from a 5-hour day to the 24-hour rhythm we know now. The moon, meanwhile, has receded to a safer, more stable orbit. Its gravitational influence softened, but still strong enough to move oceans. It is astonishing to realize that something as gentle as the tide, a rise and fall of a few meters, can shift the orbit of a moon nearly 400,000 kilometers away. But that is the nature of gravity: patient, cumulative, and unstoppable. It does not need power in the moment, only persistence through time. The oceans act as the gears in this cosmic machine, grinding ever so slowly, yet with immeasurable consequence. And so, the tides are not merely oceanic phenomena, they are planetary timekeepers. Each wave that retreats from the shore carries with it a whisper of Earth's slowing spin. Each tide that rises under the moon's gaze carries energy outward, into the vastness of space, pushing the moon along its widening path. The connection between Earth and moon is not static but evolving, written in the language of tides and time. The moon's own surface bears silent witness to this process. The ancient plains of basalt, the frozen scars of impact, the long shadows that stretch across its craters, all these have watched the slow widening of its orbit. When it was young and close, the Earth filled much of its sky. Volcanoes erupted under the strain of gravitational forces that flexed its interior. Over time, as the distance increased, the strain lessened, and the moon's heart grew cold and still. The same tides that move our oceans once shaped the geology of the moon itself. Even now, this mutual pull leaves measurable effects on both worlds. Earth's rotation gradually drifts out of sync with the atomic precision of our clocks. Leap seconds are added to account for the slowing of the planet. The moon's orbit, tracked by laser beams reflected from its surface, shows an ever-expanding spiral. The two worlds continue their ancient dialogue, each change in one, answered by a change in the other. This is the nature of the tides. Not violence, but persistence. They do not roar or tear. They whisper, shift, and reshape. The moon may move away only a few centimeters per year, but over billions of years, that whisper becomes a symphony. It alters the rhythm of Earth's days, the pattern of its weather, the stability of its spin. The tides are the pulse of the planet, driven by the steady hand of the moon. But tides do not only push the moon outward, they leave deeper marks sculpting coastlines, nourishing ecosystems, and guiding the evolution of life itself. The interplay of gravity and water has shaped the very story of Earth's biosphere. And as we follow that story through time, we discover that the tides are not merely physical phenomena. They are the bridge between motion and life, between the cosmos and the creatures that inhabit it. To stand on a shore and watch the tide is to witness gravity in motion. Each slow surge and retreat of the sea is the visible heartbeat of the Earth-Moon relationship. The tide's rhythm is older than any creature that walks the land, older even than the continents themselves. It has been pulsing through Earth's oceans since the first water gathered upon its surface. Yet behind this familiar rhythm lies one of the most intricate and far-reaching exchanges of energy in the entire solar system. When the moon's gravity pulls on Earth's oceans, it creates a slight distortion in the shape of the planet. The oceans bulge outward, following the moon as it travels through its orbit. Earth, spinning faster than the moon orbits, drags those bulges ahead. This tiny misalignment, only a few degrees, becomes the key to an immense transfer of energy. The gravitational pull of those displaced bulges on the moon accelerates it in its orbit, giving it the energy to climb slowly outward. At the same time, that same pull resists Earth's rotation, acting like a brake on its spin. It is a cosmic trade with no frictionless surface, no perfect balance. The Earth and Moon are locked in a slow negotiation that never ends. Each tide that rises against a continent, each wave that crashes onto a beach, is part of this ancient exchange. Water flows across the seafloor, losing energy to friction and turbulence. That lost energy has to go somewhere, and it finds its way into the widening of the moon's orbit. The scale of this process defies intuition. The moon moves away by about 3.8 centimeters each year, less than the width of a finger, yet that change accumulates relentlessly. Over 100 million years, it becomes nearly 4,000 kilometers. Over a billion years, tens of thousands. It is as if the Earth and Moon are slowly breathing apart, a rhythm so vast that only time itself can measure it. This retreat has been confirmed not by imagination but by experiment. When astronauts landed on the Moon, they left behind small arrays of mirrors called retroreflectors. From observatories on Earth, scientists fire laser pulses that bounce off these mirrors and return to detectors. By measuring the round-trip time of the light with extraordinary precision, they can determine the distance to the Moon down to the millimeter. Decade after decade, the results tell the same story. The Moon is receding, the orbit widening, the dance evolving. But the tides are not only mechanical, they are sculptors of worlds. The immense tidal forces of the early Earth, when the Moon was much closer, stretched and strained the young planet's crust. They may have driven volcanic activity, altered the chemistry of the oceans, and influenced the emergence of life itself. Some scientists believe that the regular flooding and draining of tidal flats created chemical environments where early organic molecules could concentrate, combine, and evolve. In this way, the tides may have been midwives of life, gravity's gift to biology. Even after life began, tides continued to shape its evolution. The constant motion of the seas created coastal ecosystems that were both challenging and rich. Organisms that could survive the alternating cycles of submersion and exposure gained new advantages. The rhythm of the tides became part of the rhythm of life, encoded in the biological clocks of species across the world. Even now, crabs, coral, and sea turtles time their behaviors to the tides, as if listening to the whisper of the moon across the water. The geological record preserves this story in patterns so subtle they almost seem impossible. Ancient corals and shell-bearing creatures lay down growth lines like tree rings, marking daily and annual cycles. In these fossils, scientists have found evidence that hundreds of millions of years ago, a year held more days, not because time was different, but because each day was shorter. Earth's rotation was faster, and the moon was closer. The fossilized rhythms of long-dead organisms are, in essence, a record of the changing gravitational bond between Earth and Moon. The tides also tell us that the Earth-Moon system is not isolated. The Sun adds its own influence, creating solar tides that either enhance or counteract the lunar ones. When the Sun and Moon align during new and full phases, their gravitational pulls combine, producing spring tides, higher highs, and lower lows. When they are at right angles, their effects partially cancel, leading to neap tides, gentler rises and falls. The interplay of these forces gives the ocean its complex breathing, a harmony of celestial geometry expressed in water. Every element of this cycle, from the smallest ripple to the greatest storm surge, is part of a balance that began with gravity and motion. The moon's distance determines the strength of its pull, which determines the amplitude of the tides, which in turn determines the rate at which energy is transferred. This feedback loop ensures that the system evolves slowly toward equilibrium. Yet true equilibrium will never be reached. The universe does not stop, it only changes its pace. The tides will continue their patient work for billions of years. The moon will drift farther until Earth's rotation slows enough to match the moon's orbit. When that happens, one side of Earth will forever face the moon, just as one side of the moon forever faces Earth. The tides will weaken, their energy exhausted, and the two bodies will settle into a serene stillness. But long before that distant epoch arrives, the sun's own evolution will change everything. As it swells into a red giant billions of years from now, the balance of forces in the solar system will be rewritten once again. For now, though, the tides continue their work as they have since the beginning. They shape coastlines, stir nutrients in the sea, and mark the passage of time for all living things. They are the visible face of an invisible connection, the trace of a conversation between two worlds that began with collision and grew into harmony. The next time you stand by the ocean and feel the water rushing over your feet, remember that you are feeling the movement of the moon, a touch transmitted across nearly 400,000 kilometers of space, through gravity, through motion, through time itself. Each tide is both local and cosmic, a whisper from a celestial companion whose pull we will never escape. The tides do not merely rise and fall, they shape the story of worlds. The slow exchange of energy between Earth and Moon has left its fingerprints on everything from the length of the day to the rhythm of the year. Long before humans watched the ocean breathe, before continents settled or creatures walked upon land, this gravitational partnership was already sculpting the face of the planet. It is a relationship written not only in water but in stone, fossil, and time itself. In the earliest days of the Earth-Moon system, the moon was much closer, perhaps only 20 times nearer than it is today. In that ancient sky, it would have appeared immense, glowing with a brilliance that cast shadows even at night. The tides it raised were staggering. Oceans heaved upward hundreds of meters, sweeping across primitive coastlines with every rotation of the planet. The friction from these titanic tides dissipated energy at an astonishing rate, heating Earth's interior, stirring its mantle, and slowing its spin. The young Earth spun rapidly then, completing one rotation in as little as 5 or 6 hours. Each sunrise and sunset came swiftly, the world turning beneath the enormous, looming moon. But with every passing millennium, The transfer of energy through the tides lengthened the day. The moon moved outward, and Earth's pace slowed. It is as though the two worlds were breathing, one exhaling rotation, the other inhaling distance. Evidence of this can be read in the ancient archives of the planet. Some of the most telling records lie in fossilized corals and microscopic sediments that preserve daily and annual growth cycles. Under a microscope, each layer tells the story of a single day, while larger bands mark the changing seasons. By counting these rings, scientists can determine how many days made up a year long ago. Fossils from hundreds of millions of years ago reveal that there were more than 400 days in a year, each lasting just over 20 hours. Over time, as the moon drifted outward, the number of days per year decreased, while the length of each day increased. This means that the slow pulse of the tides has been changing the rhythm of time itself. The clock of the planet, once racing, now turns more gently. Each wave that strikes the shore, each tide that rises under the moon, carries the faintest echo of that deceleration. It is a planetary metronome, ticking slower with every century. If you were to travel back to the ancient Earth and stand on its shores, the difference would be overwhelming. The moon would hang enormous and golden above the horizon, its features clear to the naked eye. The tides would roar, flooding the lowlands with relentless power. The short days would pass like the flicker of a heartbeat, dawn chasing dusk in rapid succession. The world would feel alive with energy, its oceans boiling with movement, its atmosphere swirling in a fast, unending wind. That dynamic world laid the groundwork for everything that would come after, from continents and climate to the evolution of life. As the moon retreated and the tides calmed, life began to spread across the shallows. The gentler cycles created stable coastal ecosystems, the first nurseries of complex organisms. The periodic flooding and drying of tidal flats became crucibles of change. Here, molecules concentrated and reacted. Early multicellular life adapted to survive both submerged and exposed conditions. The moon's gravity was not just shaping orbits, it was shaping biology. Every fish that swims and every creature that feels the pull of the tide carries a faint memory of that gravitational inheritance. Even the distribution of continents bears traces of tidal influence. As Earth's rotation slowed, the planet's equatorial bulge shifted. The flow of energy through the mantle changed slightly, influencing the slow drift of tectonic plates. The effect was minute but persistent, part of the same cosmic process that connects ocean waves to the rotation of the entire planet. It is astonishing to realize that a phenomenon as delicate as a tide can, over eons, participate in the rearrangement of continents and the evolution of climate. But the story is not one of constant calm. There have been eras when the tides were stronger or weaker, when the configuration of continents amplified or dampened their motion. When large landmasses clustered together, tidal waves traveled freely across vast ocean basins, increasing their reach. When continents drifted apart, the tides became fragmented, confined by geography. These shifts in oceanic resonance affected the rate at which energy was transferred to the moon, subtly altering its rate of recession. The Earth-Moon system, though stable in the long run, is finely tuned and ever responsive to the slow choreography of geological time. The moon's gradual withdrawal has also affected the tilt of Earth's axis and the precession of its spin, the slow wobble that traces the path of our planet's poles across the sky. The gravitational link between Earth and Moon helps to stabilize this motion, keeping our seasons regular and preventing wild swings in climate. Without the Moon, Earth's tilt could vary chaotically over millions of years, leading to extreme temperature cycles. The same tidal forces that slow our rotation also anchor our stability. Every detail of this evolving system reminds us that gravity is never idle. It does not merely hold things in place, it transforms them through persistence. The same force that keeps the moon from drifting away is also responsible for slowing the planet, regulating the tides, and sustaining the rhythm of life. The universe is not static. It is constantly redistributing energy, exchanging motion for order, chaos for balance. The Earth and Moon, born from the same fiery collision, are now partners in this long gravitational dialogue. Their relationship is written in the tides, in the length of the day, and in the slow pulse of geological time. Every second of your life, every spin of the planet beneath your feet, is slightly longer than it would have been in the deep past because of the Moon's gentle hand. But even this balance will not last forever. As the Moon continues to retreat, the tides will weaken, and Earth's spin will slow further. Billions of years from now, the two worlds will become tidally locked, showing each other the same face. The dance will not end, but it will slow to still embrace a balance so perfect that motion itself will seem to pause. For now, the tides remain the living thread between two worlds, the expression of gravity as both artist and architect. They are the visible echo of a cosmic story still unfolding. And as we turn our eyes backward through time, we can see how this exchange once shaped an Earth that spun faster and shone beneath a Moon that loomed vast and near a world where the sky was different and the rhythm of day and night moved to a quicker, deeper beat. There was a time when the Moon filled half the sky, so large that its pale plains and dark scars were visible even in daylight. The young Earth turned swiftly beneath it, a restless world, bathed in a strange silver light. Days passed in what would feel to us like hours, and the tides rose not gently but violently, sweeping across entire continents in great, rhythmic surges. The early oceans were alive with energy, the atmosphere thick and heavy with vapor and storms. To look up then was to see the Moon not as a distant ornament, but as a colossal presence, a looming companion that ruled both the seas and the rhythms of the new world. 4 billion years ago, Earth was a very different planet. Its crust was still young and thin, its air dense with carbon dioxide, methane, and water vapor. The oceans were newly formed, shimmering under volcanic skies. The Moon, born from the collision of a Mars-sized body with the early Earth, orbited far closer, perhaps only 20 times nearer than today. At that distance, it appeared 20 times larger, dominating the heavens. Its gravity pulled at the oceans with unimaginable strength, creating tides that rose hundreds of meters high. The planet's rotation was dizzying, a full day lasting only about 5 or 6 hours. The sun rose and set 4 times in what we would now call a single day. That rapid rotation gave Earth tremendous energy. Winds screamed across its surface, driving massive waves that crashed against young volcanic shores. The seas boiled with turbulence. Yet amid that chaos, patterns began to emerge, repeating rhythms of tides, cycles of day and night, surges of heating and cooling. Gravity was imposing order on the storm. The same force that tore fragments of Earth into orbit to form the Moon was now shaping the planet's climate, the behavior of its oceans, and even its geology. To the early Moon, Earth would have been a breathtaking sight, vast, luminous, and alive with color. The planet's glowing atmosphere would have shimmered with lightning storms. Continents were only beginning to form, surrounded by endless seas. From the Moon's surface, Earth would have appeared enormous, perhaps 13 times wider than the Moon looks to us now. It would have hung motionless in the lunar sky, always in the same place, because the Moon was already tidally locked, showing one face forever. The young Earth's light would have painted the lunar landscape in shifting blues, greens, and golds as clouds swirled beneath its gaze. The closeness of the Moon did not merely produce spectacular tides, it also heated Earth's interior. The immense gravitational flexing caused by the Moon's proximity stirred the mantle, driving volcanic activity and accelerating the recycling of the crust. This constant churning released gases into the atmosphere, thickening it and warming the surface. Without the Moon's pull, Earth might have cooled too quickly, becoming geologically stagnant like Mars. Instead, the gravitational friction kept it alive. The Earth-Moon system was not just mechanical. It was thermal, chemical, and biological. Over time, this gravitational heating lessened as the moon receded. The tides grew gentler, the planet's rotation slowed, and stability emerged. The long ages of wild oceans gave way to calmer seas where the earliest forms of life could take hold. Simple molecules combined and multiplied, adapting to the cycles of flooding and retreat that the tides imposed. The moon, by pulling on Earth's oceans, was unknowingly shaping the conditions that would lead to consciousness, the ability of the planet to look back at itself through the eyes of living beings. The evidence of this ancient era still lies hidden in the rocks. Certain minerals formed only in the presence of strong tidal mixing, and the oldest sedimentary patterns suggest extreme variations in sea level. Even today, geologists can read the signature of those colossal tides frozen in stone. The chemical traces left behind by early tidal pools tell a story of alternating wet and dry conditions, where evaporation concentrated minerals and allowed complex chemistry to flourish. It was in such shifting environments, driven by the moon's pull, that the first sparks of life may have flickered into existence. Imagine the view of that early Earth from space, a planet spinning so fast that its equator bulged outward, its oceans shimmering under constant motion, and a colossal moon hanging close enough to cast rippling shadows across the clouds. The interplay of light and gravity gave birth to cycles, short days, short nights, and immense tides that defined the rhythm of the young planet. The moon's nearness may even have shielded Earth from some impacts, its gravity sweeping away debris left from the solar system's formation. The bond between them was not just gravitational, but protective. As the billions of years passed, the moon drifted outward, and the violence of the early tides faded into the steady rhythm we know today. Yet that early age, when the moon's presence was overwhelming and Earth's spin fierce, left an indelible mark on the planet's nature. The faster rotation affected the formation of the magnetic field that shields us from solar radiation. The tidal flexing helped shape the continents. Even the length of the year and the tilt of Earth's axis evolved under the combined influence of this gravitational partnership. The ancient sky was both terrifying and beautiful, a world in constant motion, its seas alive, its air dense and glowing with volcanic fire. The moon's light would have flickered across steaming waters, casting long, trembling reflections that marked the birth of rhythm itself. Day and night alternated in quick succession, but the tides persisted, vast and slow, connecting each moment to the next. It was a world that felt the pulse of gravity with every breath. To understand how far we have come, we must look back to that time when Earth spun so fast that a day was little more than an echo, and the moon's pull was not a distant tug, but a roar across the heavens. For in that roaring world, balance began to take shape. The tides started their patient work. The orbit began to widen, and the long dialogue between two worlds entered its first, furious chapter, the beginning of a cosmic friendship that would define the fate of both. The young Earth was a world ruled by speed and light. Its rotation was furious, its surface restless, and its tides immense. The moon circled close and fast, completing an orbit in only a few days. The two bodies were locked in a gravitational tension that shaped everything about their evolution. The tides did not merely move water, they shaped the rocks, the air, and even the length of time itself. Every moment on that young planet passed differently, faster, brighter, louder. It was as though the entire world was still trembling from its own creation. In those early days, the energy of the Earth-Moon system was staggering. When the moon first coalesced from the ring of debris that formed after the Great Impact, it orbited through a sky filled with molten fire and drifting rock. Earth glowed red-hot from the energy of its birth, its surface a sea of magma. The moon's gravity raised tides not only in the new oceans that were beginning to form, but in the molten rock itself, flexing the planet's crust and stirring its interior. This constant kneading helped Earth cool from the inside out, mixing materials, forming the first continents, and setting the stage for the planet's long geological story. As the crust solidified, Oceans began to spread across the cooling surface. Water vapor condensed from the thick, hot atmosphere, falling in endless storms that filled the basins and carved primitive river valleys. The moon's gravity was the first sculptor to touch those waters. The early tides surged across vast distances, washing against mountains still forming from the molten crust. Each rise and fall of the sea helped to erode and redistribute minerals, feeding chemical cycles that would eventually support life. The moon's nearness made these cycles far more intense than they are today. The tides did not creep along the shorelines, they roared like floods. The young atmosphere, heavy with greenhouse gases, trapped heat close to the surface. Lightning flashed through the thick haze. Volcanoes erupted in great plumes of steam and dust. Amid this violent backdrop, the rapid rotation of the planet created powerful winds that whipped across the oceans. The moon's tidal forces added their own rhythm, tugging at the surface waters and slowing the rotation slightly with every cycle. The combination of spinning and pulling, of heat and motion, made early Earth a world of extremes, but also a world of balance in the making. As the moon's orbit widened and Earth's rotation slowed, the difference between day and night began to matter more. Longer days allowed the planet to cool more efficiently. The changing rhythm of sunlight influenced temperature cycles, winds, and the movement of the seas. Over millions of years, the tidal energy that once churned the oceans with violence began to shape them with subtlety. Stable patterns of currents emerged. The first climate systems were born. Gravity, working hand in hand with time, was teaching the planet how to breathe. The evidence of this transformation still lies hidden in the deep past. Ancient zircon crystals, more than 4 billion years old, contain chemical signatures of interaction between rock, water, and atmosphere, proof that the tides were already at work, cycling material from ocean to land and back again. These crystals preserve the earliest whispers of a planet finding equilibrium under the influence of its moon. Later, in younger rocks, geologists find tidal sediments, rhythmic layers of sand and silt that record ancient ebb and flow. Each layer marks the passing of a tide, a physical imprint of gravity's presence across billions of years. It is remarkable that these delicate traces survived. The continents have shifted, collided, and reformed countless times since then. Yet the pattern of the tides has persisted. Even when Earth froze during ancient ice ages or burned during volcanic cataclysms, the moon's pull continued unbroken. Gravity does not forget. It imprints its rhythm deep within the fabric of the planet. In every cycle of erosion, deposition, and renewal. In those ancient centuries, the closeness of the moon also influenced Earth's internal rhythm. The constant tidal stress acted like a slow hammer, dissipating heat from the mantle and keeping the planet's core active. That movement helped sustain Earth's magnetic field, the invisible shield that protects life from the charged particles of the solar wind. Without this field, the atmosphere might have been stripped away long ago, leaving the planet barren. In this sense, the moon's pull did more than move water. It preserved the conditions for habitability itself. Scientists now use complex computer models to reconstruct these early interactions. By calculating backward from the current rate of the moon's retreat, they can estimate how the day length and orbital distance have changed through time. The models show that when the first stable oceans formed, the day was only about 6 hours long, and the moon was less than a tenth of its current distance away. The tides then were hundreds of times stronger, the energy exchange millions of times greater. Yet even as that energy tore at the planet's surface, it also built the stable partnership that endures today. It is a paradox, both humbling and beautiful. The same gravitational forces that once nearly destroyed Earth through chaos and heat are the same forces that later made it calm, fertile, and steady. The early violence of the tides softened into the rhythm of life. The furious spin of the planet slowed into the measured pulse that now governs the rotation of days and nights. The closeness of the moon gave way to the graceful distance we see now, far enough for beauty, close enough for influence. If one could stand on the shore of that primeval world, the spectacle would defy imagination. The moon would rise enormous, glowing amber through the thick air, its reflection stretching in trembling light across the waves. The tides would race outward, then rush back, reshaping the coastlines with every cycle. Volcanoes would flash red against the horizon, lightning would crack through the clouds, and the air would shimmer with heat. Yet beneath the chaos there was pattern, beneath the violence there was order. Gravity was already guiding the world toward balance, one tide at a time. From that fiery beginning, the Earth-Moon partnership has evolved into a masterpiece of stability. The young moon's nearness gave Earth its first rhythm. Its slow retreat gave Earth its long-term balance. Every wave that breaks today, every rise and fall of the sea, carries the memory of that ancient closeness. The tides we know are whispers of a force that once roared across the surface of a newborn world. And as we trace this story through time, we find that the past is not gone. It lives in every motion of the sea, every rotation of the planet, every orbit of the moon. The ancient sky may be lost to our eyes, but its legacy endures in the calm of the present world. The same force that once moved mountains now merely stirs the waves. Yet it is the same force, still gravity, patient, eternal, and faithful to the first rhythm it ever played. The ancient Earth carried the scars and the memory of its closeness to the moon. The story of that intimacy is written in the layers of rock, the growth rings of ancient organisms, and the rhythm of time itself. Though billions of years have passed, the echoes of that early gravitational bond remain clear to those who know how to read them. The tides have always been the planet's chronometer, marking not only the passage of days but the evolution of an entire world. When the moon was close, the Earth rotated swiftly, completing a day in only a handful of hours. As the planet's rotation slowed, the pattern of sunlight and shadow changed, and so did the behavior of everything that depended on it. Fossilized coral and stromatolite colonies reveal this through their intricate growth bands. Under magnification, their skeletons show alternating layers that match the daily and seasonal cycles of their environment. These records tell us that hundreds of millions of years ago, a year held more than 400 days, each one just over 20 hours long. The tides came faster then, and life adapted to their relentless rhythm. These fossils are more than remnants of biology. They are the diaries of the planet's motion. Each band of calcium carbonate, laid down by a coral polyp, records the timing of tides, the pulse of the moon's gravity. By counting those bands, scientists have reconstructed the changing tempo of Earth's rotation. It is through this patient reading of stone and shell that we know the moon has been drifting outward for billions of years, and that the length of our day has been growing, second by second, century by century. But the moon's influence was not limited to the clockwork of time. Its gravity also shaped the climate, the geology, and even the distribution of life itself. The immense tides of the early Earth mixed the oceans thoroughly, circulating nutrients and heat. The constant stirring prevented stagnation, keeping the young seas rich and dynamic. This mixing may have been essential for the development of early life, ensuring that the chemical building blocks of biology were distributed across the planet's waters. In that sense, the moon acted as the first planetary engineer, its gravity maintaining the balance of energy and chemistry that made Earth habitable. Over time, as the moon drifted farther away, the tides weakened and the planet's rotation slowed. The gentler conditions allowed ecosystems to stabilize. Coastal habitats became nurseries for life, their periodic flooding and draining offering both challenge and opportunity. Early organisms learned to adapt to the rhythm of the tides, synchronizing their behavior with the pull of the moon. The daily cycles of feeding, reproduction, and migration that still guide countless species today are echoes of that ancient gravitational rhythm. Yet the influence of the moon reaches even deeper. The stability it provides to Earth's axial tilt ensures that seasons change predictably, a crucial factor for the evolution of complex life. Without the moon, Earth's axis might wobble wildly under the gravitational pull of other planets, leading to catastrophic climate swings. Ice ages could follow in rapid succession, Deserts could become frozen plains, and no stable environment would persist long enough for higher life to evolve. The same moon that once raised tides hundreds of meters high now keeps the planet steady and temperate. Geologists studying ancient sediments have discovered evidence of the moon's gradual withdrawal in the rhythmic layering of tidal deposits. These strata form where strong currents meet shallow shelves, leaving behind alternating layers of coarse and fine grains. The thickness and spacing of these layers correspond to the frequency and strength of tides. By comparing ancient patterns with modern ones, scientists can determine how the moon's influence has changed over eons. In this way, even stone bears silent witness to the slow expansion of the orbit and the lengthening of the day. The ancient sky was a theater of movement. The moon rose swiftly, crossing from horizon to horizon in only a few hours. Its light was fierce, casting shadows so sharp that the night looked like day painted in silver. The tides followed this rapid rhythm, rising and falling multiple times during a single short day. To early life, this must have been the defining rhythm of existence, a world governed not by hours or months, but by the heartbeat of the sea. Imagine standing on a coastline of that distant era. The air is thick and hot, filled with the scent of salt and minerals. The ocean roars as a tide, hundreds of meters high, rushes toward the shore. In the sky, the moon looms vast and brilliant, its cratered surface etched with sunlight. The horizon trembles under its glow. The ground beneath your feet vibrates as the water advances, then recedes, over and over again, each cycle echoing through the crust. This is gravity, not as a quiet whisper, but as a thunderous voice, shaping the very face of the planet. As the eons passed, the roar softened to a murmur. The moon retreated, the tides calmed, and the world began to settle into its long, slow rhythm. The earth that emerged from that transformation was gentler, more balanced. The days lengthened into the familiar 24 hours, and the tides became the tranquil waves that define our coastlines today. The ancient violence gave way to harmony. The partnership between earth and moon had matured, yet the past is never lost. It lives in the present, in the slow drift of the moon, in the quiet rise of the sea, in the rhythmic turn of the planet. Every movement of water, every sunrise, every orbit is part of the same story that began 4.5 billion years ago. The moon's distance today, so perfectly balanced for stability and beauty, is not a coincidence. It is the outcome of billions of years of tides, friction, and motion, the patient work of gravity refining its own masterpiece. The ancient sky has faded, but its legacy endures. The faster Earth and the closer moon are gone, yet their influence remains written in everything that moves. The waves that lap against the shore, the gentle pull that guides the tides, the stability that cradles life, all are the lingering gifts of that early, intimate age. And as the moon continues its slow retreat, the bond remains unbroken, a connection of motion and gravity that will outlast the continents themselves. The next chapter in this story will show what this bond truly means, how the moon, once a chaotic companion, became Earth's great stabilizer, holding our world steady against the turbulence of cosmic time. The moon is more than a bright shape in the night sky. It is the quiet engineer of Earth's balance, the hidden architect behind our gentle seasons, and the silent guardian that prevents chaos from spilling into our skies. Without it, the tilt of our planet would swing wildly, and Earth would be a place of unpredictable extremes, a world where glaciers could form at the equator one age and melt into jungles the next. The moon's steady pull is what keeps that from happening. Earth spins like a tilted top, leaning about 23.5 degrees as it travels around the Sunday. This tilt gives us seasons, warmth and cold, planting and harvest, the slow rhythm of life. But this tilt is not fixed in space. The gravitational pull from the giant planets, especially Jupiter, constantly tries to tug Earth's axis into new directions. Without something to hold it steady, the tilt would wobble by dozens of degrees over long stretches of time. The result would be catastrophic. Oceans would freeze and thaw in strange cycles. Climates would lurch from tropical to polar, and no stable environment would endure long enough for life to evolve. The moon prevents this. Its gravity acts like an anchor on Earth's equator, resisting the pulls of the other planets. The moon's presence dampens those dangerous wobbles, confining the tilt to only gentle variations. Over tens of thousands of years, this small oscillation shifts sunlight patterns just enough to create the natural rhythm of ice ages, but not enough to destroy the balance of the biosphere. The moon is, in effect, Earth's gyroscope, keeping its spin aligned, its rhythm stable, and its face always within the narrow range that allows oceans and forests to exist. If the moon were gone, Earth would begin to behave like Mars. With no large moon to steady it, Mars's axis wanders by as much as 60 degrees. Sometimes its poles point almost directly at the sun, melting ice and flooding the lowlands. At other times, they tilt away, freezing the planet solid. These cycles happen over spans of only a few million years, a blink in planetary time. A moonless Earth would have suffered the same fate, its history rewritten by the chaos of the cosmos. The moon also helps to smooth the Earth's rotation. As tides rise and fall, friction transfers a bit of energy from Earth's spin into the moon's orbit. This gradually slows the planet's rotation, lengthening our day by a fraction of a second each century. Yet, in slowing Earth down, the moon also stabilizes it. Like a skater spreading their arms to stop spinning too fast, Earth finds calm through this exchange. The planet's spin becomes more even, its axis steadier, its climate more predictable. All of life depends on this quiet order. Stable seasons mean reliable rainfall and consistent growing periods. Over millions of years, plants evolved to follow the calendar of sunlight. Animals learned to migrate with the turning year, and entire ecosystems arose around the predictability of time. Civilization itself, agriculture, cities, and history became possible only because the planet's rhythm stayed dependable. The moon's steadying hand is hidden in every harvest and every calendar ever made. Even the slow drift of the equinoxes, the long precession of Earth's axis over 26,000 years, is governed by the moon's influence. It moderates the rate of this motion, keeping the distribution of sunlight within tolerable limits. The great ice ages that come and go are guided not only by the sun and the shape of Earth's orbit, but also by the precise balance maintained by the moon. It is the unseen regulator of climate over geological time. If one could remove the moon from the sky in an instant, the consequences would unfold slowly but inexorably. Within millions of years, the tilt of the planet would begin to wander. The seasons would grow violent. Ice might form in places where jungles once stood, and deserts might bloom briefly before freezing. Life would adapt and collapse, adapt again, and fail once more. In the long view of time, the loss of the moon would erase the quiet rhythm that sustains the Earth we know. When we look up at the moon tonight, pale and distant, we are seeing the very reason we can exist in peace. Its light may be gentle, but its influence is vast. It steadies our axis, slows our spin, and softens the restless motions of the cosmos. It has watched over the rise of life and the birth of intelligence, holding our world still enough for thought to take root. Someday, this balance will end. The moon continues to drift away at a rate of nearly 4 centimeters each year. As it retreats, its stabilizing power will weaken. In the far future, billions of years from now, Earth's tilt may begin to wander again. But long before that happens, the sun will have changed, and both Earth and moon will be caught in new tides of destruction and renewal. For now, the balance endures, and the bond remains strong. The moon is not only a companion of light, it is the hand that steadies the cradle of life, a silent guardian that has kept Earth's face turned toward calmness through 4.5 billion years of motion. Its work is invisible, its influence immeasurable, and its presence essential. Without it, there would be no stable world, no steady seas, no predictable dawns. The moon does not simply orbit Earth. It holds it steady, teaching the planet how to endure the passage of time without losing its balance. Every night we see the moon glide across the sky, glowing softly above the restless surface of the Earth. It feels eternal, a fixed companion whose presence seems as old as the world itself. Yet the truth is more fragile and more poignant. The moon is slowly leaving us. It drifts away each year by the width of a thumb, a tiny distance that adds up over time to something immense. The bond that has tied Earth and Moon together for 4.5 billion years is not unbreakable. Gravity is strong but not absolute, and even the tightest embrace in the cosmos must one day loosen. The cause lies in the tides. As Earth spins, its oceans bulge slightly toward and away from the moon. Because the planet rotates faster than the moon orbits, those bulges are dragged ahead, pulling on the moon like a handle. The tug gives the moon a little extra momentum, pushing it into a higher orbit. To conserve angular momentum, Earth's rotation slows by the same amount. The moon moves outward, while the planet's day lengthens, an invisible trade of energy that has been going on since the beginning. This drift has been measured precisely with the help of mirrors left on the lunar surface by astronauts. Laser beams sent from Earth bounce back with exquisite accuracy, revealing that the distance grows by about 3.8 centimeters each year. That may not sound like much, but over tens of millions of years it becomes vast. In 100 million years, the moon will be nearly 4,000 kilometers farther away. In a billion years, tens of thousands. It is as though the sky itself is slowly exhaling. As the moon recedes, its gravitational influence weakens. The tides become gentler, the days grow longer, and the planet's rotation steadies further. But this calm is only temporary. Eventually, after billions of years, Earth and Moon will reach a new balance, a state called tidal lock. In that future age, the Earth's rotation will slow until it matches the Moon's orbital period. The same side of Earth will then always face the Moon, just as the same side of the Moon faces us now. The dance will end in perfect symmetry. In that far era, a single day and a single month will last the same length of time, about 47 of our current days. The tides will be frozen, rising and falling weekly in the same places, bound by the locked geometry of two worlds that have finally synchronized their motion. To an observer standing on Earth, the moon will no longer rise or set. It will hover eternally above one hemisphere, fixed in the same spot of the sky. On the far side of the world, the moon will never be seen again. For a while, this double lock will hold. The Earth-Moon system will move as one through space, bound in a shared orbit around the Sunday. But nothing in the cosmos is truly permanent. The sun itself is changing, and its slow transformation will eventually rewrite the fate of both worlds. As the sun ages, it will swell into a red giant, its outer layers expanding beyond the orbit of Mercury and Venus. When that time comes, billions of years from now, the tidal pull of the swollen sun will overpower the gentle balance between Earth and Moon. As the sun's gravity grows stronger relative to their own connection, the Earth-Moon pair will begin to unravel. The Moon's orbit may widen beyond the point where it remains stable. Solar tides could slowly strip it from Earth's influence, capturing it into an independent path around the dying star. Some models suggest it could drift away peacefully, becoming a lone wanderer of the red giant's light. Others imagine a more violent end, where the moon spirals inward, torn apart by gravitational stress and scattered into a glowing ring of debris before finally merging with the Earth. Whichever future unfolds, the process will take longer than life itself. The continents will have shifted beyond recognition, the oceans will have boiled away, and the sky will have turned copper with the glow of the aging sun long before the moon's departure reaches its final act. Yet the slow retreat continues even now, each tide carrying away an infinitesimal fragment of connection. each century widening the gulf between our world and its companion. It is a strange and beautiful thought that the same force which joined Earth and Moon now pushes them apart. Gravity gives and takes in equal measure. It is not only the bond that holds things together, but the mechanism by which they evolve. The Moon's departure is not a failure of gravity, but its fulfillment. The system moves toward balance, toward rest, toward the stillness that all motion eventually seeks. If some distant descendants, or perhaps machines left behind, could watch from the surface of that future Earth, they would see a smaller moon than we do now. Its angular size would shrink, its influence on tides diminish. The beauty of a total solar eclipse, where the moon perfectly covers the sun, would be lost forever. The alignments we witness today are a fleeting coincidence in cosmic time, a precise geometry that happens only now, in this brief window of history. The moon's slow retreat teaches us something profound about change. We live in an era of perfect balance, unaware that the harmony of our sky is temporary. The same tides that shaped our coasts, regulated our climate, and guided the rhythm of life are also carrying our companion away. We exist in the middle of a long farewell, one so gradual that we will never feel it, but one that defines the destiny of our planet. One day, far in the future, when Earth turns slowly beneath a dimming sun, the moon will no longer circle it as it does now. Whether it drifts into the void or merges in a final blaze of reunion, the bond will end, but the legacy of that bond will never fade. It is written into the shape of our planet, the length of our days, the rhythm of our oceans, and the history of every living thing that ever looked up. When the moon finally leaves us, the Earth will still remember its rotation, its tilt, its tides. All will carry the memory of their long partnership. The moon's influence will echo in the calmness of the planet it helped to shape, in the lingering stability it left behind. And long after it is gone, the night sky will hold its absence like a scar, a reminder of the silent guardian that once watched over the world, keeping it steady, teaching it balance, and then, like all faithful companions, drifting quietly into the dark. Gravity binds not only Earth and Moon but the entire cosmic family. Every orbit, every tide, every steady rhythm of motion in the solar system is part of one vast network of invisible threads. The moon does not merely orbit Earth. Both together move in a graceful waltz around the sun, influenced by the pull of every other planet. To understand this relationship is to see that the bond between Earth and Moon is not an isolated duet but a single part of a greater symphony, the cosmic order written in motion. Earth and Moon revolve around a shared center of gravity, a point called the barycenter. This point lies inside Earth, but not at its center. As the Moon moves, Earth wobbles slightly in response, both bodies circling that mutual center, like dancers, linked by an unseen cord. To an observer in deep space, neither Earth nor Moon travels in a perfect path around the Sunday. Instead, they move in intertwined loops, their orbits woven together by gravity's patient precision. The same force that governs their motion ties them to the Sun and in turn to the rest of the solar system. The planets, moons, and asteroids are like notes in a vast gravitational chord, each influencing the others in ways that may be faint but never trivial. Jupiter's immense pull shapes the orbits of countless objects, even subtly tugging on Earth's path. Saturn's moons interact in resonant patterns that keep their orbits stable. Everywhere, the same law of attraction applies, binding small and great alike into harmony. The Earth-Moon system itself is part of that larger conversation. The Moon's gravity slightly affects how Earth moves around the Sunday. It modulates the tilt, the precession, and even the eccentricity of the orbit. These effects, though subtle, contribute to the slow climatic rhythms that shape the history of life. The Milankovitch cycles, those long oscillations in Earth's tilt, orbit, and distance from the Sun, are influenced not only by the other planets, but also by the presence of our Moon. Without it, the song of the seasons would change its melody completely. Gravity connects not just worlds, but the histories of those worlds. The same pull that keeps the moon from drifting away keeps Earth tethered to the sun bound to the Milky Way, and the galaxy drawn toward the great structures of the cosmos beyond. It is the common thread that runs from the smallest grain of dust in a comet's tail to the superclusters of galaxies stretching across billions of light years. When we trace the moon's orbit, we are following one link in the chain of the universe itself. Within this grand network, resonances form repeating ratios between the motions of planets and moons that reinforce stability or create chaos. The moon's motion is locked in a resonance with Earth's rotation. Similarly, the orbital periods of many moons around Jupiter and Saturn align in patterns that keep their systems balanced. These gravitational harmonies are nature's way of maintaining order amid motion. Even the slightest perturbation can, over time, echo across the whole system, reminding us that gravity is not static, but alive with interaction. In the early solar system, these resonances were the architects of stability. Without them, planets might have collided or been ejected into the void. The same mathematical relationships that guide the Earth-Moon system govern the formation of everything we see today. Each orbit that holds steady, each world that circles without falling, is a triumph of balance between motion and attraction. If one could observe the solar system from afar, stripped of light and matter, so that only gravity remained visible, it would look like a vast web of threads vibrating gently with energy. Each intersection marks a world, each vibration a force exchanged. The moon's path around Earth would shimmer like a small, bright loop connected to a larger strand, the orbit around the sun, which itself would twist through the galactic field. Everything moves together, every part influencing the whole. For humanity, the moon is our nearest bridge to this cosmic web. It has been both a mirror and a teacher. When Isaac Newton looked at the moon's path, he saw the same force that causes an apple to fall. From that realization, the universal law of gravitation was born a single equation that could describe both the tides of Earth and the motions of the heavens. Centuries later, Einstein expanded that idea, showing that gravity is not a force at all, but the curvature of space and time shaped by mass and energy. The Earth bends space, and the moon moves along that curve, forever falling around it, but never touching. The beauty of this understanding is that it connects everything. The same curvature that keeps the moon in orbit also holds the atmosphere to the planet, guides the path of comets, and carries the light of distant galaxies through the cosmos. Gravity has no boundaries. It links the smallest drop of rain with the vast spiral arms of galaxies. It is the only true universal relationship, one that needs no medium, no message, no contact beyond existence itself. Even in this cosmic web, the moon's presence is special. It is our constant reminder that gravity is not a chain, but a harmony. The moon does not hang in the sky because it is tethered. It moves freely, balanced perfectly between falling and flying. Its motion expresses the same principle that shapes all things, energy and curvature in eternal dialogue. The moon's orbit is the simplest example of how the universe keeps time. If the moon were gone, Earth would still orbit the sun, and the planets would still follow their paths. But something deep would be missing, not just in the mechanics of tides and tilt, but in the poetry of the cosmos. The Earth-Moon partnership is a local expression of a universal truth, that nothing moves alone. Every motion creates a response. Every orbit shapes another. The symmetry of the sky is a reflection of an underlying unity, the same unity that holds stars in galaxies and galaxies in clusters. When you stand under the night sky and look at the moon, you are not looking at something separate from you. You are seeing the nearest link in the vast gravitational chain that binds all existence together. The pull you feel toward the Earth, the weight beneath your feet, is part of that same force that keeps the moon aloft. It is the same geometry that holds planets to the sun, that curves the path of light, that organizes the structure of the universe. You are within it, shaped by it, carried by it. Gravity connects everything, and through the moon, we can see its reach. It is the quiet thread of unity between all things, the invisible bridge between Earth's waves and the farthest galaxies. The moon's orbit is only one loop in the infinite pattern, but in that loop, the entire story of the cosmos is written: motion, balance, and the graceful inevitability of connection. Long before equations explained its orbit, before telescopes revealed its craters, the moon lived in the human imagination as a god, a clock, a mirror, and a mystery. It ruled the tides, the crops, and the moods of people who looked up at it in wonder. The moon was the first map in the sky, the first cycle of time, and the first proof that the universe moved in a rhythm. For as long as there have been eyes to see and minds to dream, it has been our most constant companion, both a physical presence and a symbol of everything beyond reach. In the earliest myths, the moon was a living being. To the Sumerians, it was the god Nana, keeper of time and fertility. To the Egyptians, it was Thoth, the measurer of knowledge. The Greeks saw Selene driving her silver chariot across the night. In every ancient culture, the moon was more than light. It was law. Its phases governed planting and harvest. Its return marked the passage of months, and its eclipse foretold omens that could shake empires. Long before the motions of planets were understood, people could trust the moon to return. It was the sky's promise of continuity. The moon's phases gave humanity its first sense of time. Before calendars or clocks, early farmers followed the waxing and waning light to know when to sow and when to reap. Each full moon was a signal: the harvest moon, the hunter's moon, the planting moon, dividing the year into manageable pieces. The rhythm of the moon became the rhythm of life. Even the word month traces back to it. In this way, the moon taught humanity to measure its days, to plan, and to look forward. Civilization began with that rhythm. The moon also ruled the imagination of the night. In its pale glow, ancient travelers found their way across deserts and seas. Poets and storytellers found metaphors for love and loss, rebirth and death. The moon changed, yet remained the same, and in that paradox, people saw their own reflection. Its cycles mirrored human life: waxing youth, full maturity, waning age, and the dark silence before renewal. To look at the moon was to look into the pattern of existence itself. Science did not erase that wonder. When Galileo first turned his telescope toward the moon, he saw mountains and valleys instead of divine perfection. The revelation was not that the moon was ordinary, but that it was another world. For the first time, humanity realized that the heavens were not unreachable. The moon became a bridge between myth and reality, a place where imagination could meet evidence. From that moment, the moon became both subject and destination. Poets dreamed of flying there centuries before rockets existed. Scientists calculated its distance and mapped its shadows. Painters filled canvases with its light. Musicians wrote odes to its phases, and philosophers saw in it the measure of cosmic harmony. The moon has never belonged solely to science or art. It is the shared language between them. When humans finally set foot upon it, the world saw more than a technological triumph. The Apollo missions were the culmination of an ancient longing, the fulfillment of a story that began when the first person lifted their eyes to the night. The footprints left on its surface were not just marks of exploration, but symbols of connection. For a brief moment, humanity stood where myths were born and turned to look back at Earth, a blue and white sphere hanging in the blackness, fragile and whole. The moon taught us what home looked like. Even after that journey, the moon remains a muse. It continues to stir emotion in the way it rises, silent and enormous, above the horizon. Artists still use its light as metaphor for change, for mystery, for the pull of forces unseen. Its gravity tugs at oceans and hearts alike. Though we now understand the equations that describe its orbit, that knowledge only deepens the awe. Knowing how something works does not diminish its wonder. It reveals its elegance. Across cultures, the moon has been the measure of beauty and time. the face of gods and lovers, the keeper of rhythm and reflection. It unites all people in a shared act of looking upward. The same moon that guided ancient farmers guides astronauts today. The same tides that shaped coastlines shape imagination. Every story told beneath its light, from myth to science, belongs to the same human lineage, the impulse to understand our place in a universe of motion. The moon's greatest role may not be in its gravitational pull or its stabilizing force, but in what it awakens within us. It reminds humanity that even in darkness, there is light, that change follows pattern, that beauty can be both eternal and fleeting. It connects every generation through the shared experience of wonder. Its slow phases are a mirror of patience, a reminder that the universe moves not in haste but in rhythm. Even now, as telescopes watch galaxies and probes cross the outer planets, the moon remains our first and closest mirror. It reflects sunlight, but it also reflects thought, our curiosity, our longing, our endless search for meaning. The same gravity that binds it to Earth binds imagination to the stars. Every glance upward is a continuation of that pull. The moon was our first teacher, our first calendar, our first dream, and though we have walked upon it, we still have not left it behind. Its light still falls across every sea and every human heart, drawing us, night after night, back into its quiet orbit of wonder. The story of Earth and Moon is a story of motion and memory, of gravity shaping time itself. It began in fire and collision, when a newborn Earth was struck by a wandering world, and from that chaos came two companions, one vast and living, one pale and reflective. From that single act of violence, a relationship was born that would last billions of years. It is a bond not of chains or contact, but of attraction, invisible, patient, and absolute. The moon has circled Earth more than 50 billion times since then, always falling, but never landing, always leaving, but never gone. It tugs at the oceans, slows the planet's spin, and steadies its tilt. It has seen continents drift, climates rise and fall, and life emerge from the sea. Every creature that has ever looked up at the night sky has seen the same light. Every tide that has ever touched a shore has moved in rhythm with its pull. Through all of Earth's transformations, the moon has remained constant, not unchanged, but faithful. Gravity keeps them together, but their relationship is not static. With every tide, a little energy slips away, a fraction of momentum traded from Earth's rotation to the moon's orbit. The moon drifts outward, millimeter by millimeter, century by century, a slow farewell written in the movement of the seas. Earth's days grow longer, the moon more distant. Their bond endures, but it evolves a reminder that even in the cosmos, love and loss are the same motion measured over different scales of time. We live in a moment of perfect balance. The moon is now at just the right distance to appear the same size as the sun in our sky. It can cover the solar disk completely during an eclipse, revealing the sun's outer corona, a coincidence that will not last forever. Millions of years from now, as the moon continues to drift away, total eclipses will fade into history. The geometry of the sky will change, and something once breathtakingly ordinary, the passing shadow that once silenced civilizations, will vanish forever. Yet this fleeting perfection is what makes it precious. The bond between Earth and Moon reminds us that beauty often exists only in transition. Every tide, every orbit, every eclipse is a conversation between motion and gravity, between holding and letting go. The universe has written this dialogue across space and time, and Earth and Moon have been reciting it since the beginning. Their connection reaches deeper than mechanics. Without the moon, Earth's tilt would wander wildly, its climates unstable, its seasons unpredictable. The gentle hand of the moon keeps the planet's axis steady, allowing life to flourish under consistent rhythms of sunlight. The same force that moves the oceans has kept Earth habitable. Our very existence depends on that quiet stabilization, on the soft, gravitational restraint of a companion we can never touch. The moon's influence has shaped not only our environment, but our understanding of the universe. It gave us the first measure of time, the first map of the heavens, the first sense of pattern and recurrence. Its phases taught early humans to count, to predict, to imagine cycles beyond a single life. It guided navigation across oceans, determined calendars, and inspired stories that turned wonder into meaning. Even now, though we understand its nature in the language of physics, it continues to speak in the older tongue of mystery. When astronauts left footprints on its dust, they did not sever the myth, they deepened it. They turned imagination into history. Those grey plains, silent and still, became a reflection of our own fragility. From the moon, Earth is small, glowing, and whole. It turns slowly in the black sea of space, blue with water and white with cloud, a living world held together by the same invisible thread that binds it to its companion. To look at Earth from the moon is to understand gravity, not as a force, but as a relationship, one that sustains, shapes, and defines. Even after the moon finally drifts too far to cast total eclipses, after its tides weaken and its stabilizing influence fades, its legacy will remain. The planet it steadied will continue to spin, its rotation slowed but sure, its shape carved by the tides that once roared with more power. The moon's absence will not erase its touch. It will only mark the end of a long era of companionship. Someday, the bond will break entirely. Perhaps the swelling of the sun in its final age will tear the moon from orbit, or draw both worlds into its fiery grasp. Perhaps, eons before that, the moon will slip away into the deeper reaches of the solar system, a faint grey wanderer, carrying the memory of home. But even then, the echo of its pull will remain in the structure of the Earth in its day length, its tilt, its calm. The planet will still bear the rhythm the moon once taught it. When that time comes, there will be no watchers left to see the final departure, but the story of their bond will still exist, woven into the mathematics of motion and the poetry of memory. For gravity, once written, is never erased. The paths of Earth and Moon are inscribed in the fabric of space-time itself, their dance frozen as a pattern in eternity. The moon has always been a mirror reflecting not only sunlight, but the story of what it means to be bound and free at once. It shows that connection need not be contact, that closeness can exist across distance, that two worlds can share one fate without ever touching. It is a cosmic truth, written in orbit, that gravity is not the pull of matter alone, but the shape of relationship, the geometry of belonging. In the end, the moon's greatest lesson is not about physics, but perspective. It teaches us that balance requires motion, that harmony is born from tension, and that separation does not mean loss. The Earth and Moon have been partners in this truth since their creation, proving that gravity's deepest power is not its strength but its constancy. It does not take chains to hold the moon, only gravity, an invisible bond that has guided two worlds through 4.5 billion years of cosmic time, whispering across the dark. That connection, once made, never truly fades.